Hi there. Okay, in this video I'm going to work through a natural deduction problem in FOL with you. So I'm going to take one of the problems from the file I've uploaded to Canvas as additional FOL derivation problems. These are taken from the textbook What Follows by Russell Marcus, which you can find by Googling, but I'll put a link to the textbook in the description on YouTube and the text I put on Canvas. Just a word about this video. The way the problems are set out in the textbook, you've got premises on the left and conclusions over on the right. So I'm just going to have to move this thing around to show you which part of which thing we're doing. Okay. Let's start with how to set the problem up on the OpenLogic project website. Make sure that you click over from TFL to FOL syntax so that the computer knows how to understand the stuff you're typing in. A little funny thing you'll need to notice, so when we're working in FOL, sometimes a capital letter A, a capital letter A is one way you can tell the system you want a universal quantifier. A capital E is a way you can tell it you want an existential quantifier. That means we can't use A or E as predicate letters, because then the system will think you're trying to write a quantifier and not a predicate letter. So when we have a problem we want to do that uses A or E as a predicate letter, we're going to have to replace those with some other letter. So if we're doing problem 1 here, we notice there's a predicate A that appears in 2 of the premises. What other predicate letters do we have? We've got a B, we've got a C, that's it. So when I type this problem in, I'm going to replace the A's with D, because that's a predicate letter we haven't used yet. So we'll have something with, if I replace all of the A's with D's, we'll be doing an argument with the same form. Okay, so let's type them in. First premise, universal quantifier, open bracket, existential quantifier, bxy, arrow, that horseshoe symbol in this other symbol, remember, is an arrow. And now AX or CX, but remember I want to replace A with D, CX, close bracket, comma, second premise, existential quantifier Z, open bracket, not DZ, that big dot is an AND, not CZ, close bracket, and my conclusion is existential quantifier Z, universal Y, not BZY. And I'm going to click Create Problem. Okay. Let's scroll down here. Okay. Remember, always first thing you need to do, the way the website sets things up, it'll put the premises in for you, but you have to put the conclusion in yourself. So I'll just copy paste that. All right. Here we go. Let's think. Okay, plan A. You remember plan A. I know you remember plan A. Plan A is work backwards with an introduction rule. But remember, there's one sneaky exception. Right? When we were working in TFL, we said, I don't trust an or working backwards. So if I had an or sentence, I would only use or introduction working backwards if I was very sure that I could get one of the disjuncts. Remember, now that we're in FOL, existential is kind of like a disguised or. So the main connective here is that existential quantifier. But I don't feel confident that I could use existential introduction working backwards, because what that would tell me to do is get something like this. For all y, not b something y. So replace the z down here with some name. Doesn't have to be a new name, it can be one I've used before, but the thing is, I would have to now, if I'm going to use existential introduction as my last step, I'd have to be able to get this. I'd have to be able to show that there's some object A such that for all y, A doesn't bear the relation B to what. That seems too strong to me. Maybe you aren't sure whether that's something you could get from your conclusions. If you're not sure, then I say go to plan B. Okay, so you don't have to be sure that you can't get that goal, but as long as you're not sure you can get it, you should go to plan B. Okay, plan B is start at the top, use elimination rules working forwards. So we have a universally quantified sentence. I could do universal elimination. And we have an existentially quantified sentence, so I could do existential elimination. Remember, I suggest that when you have a choice between different things to do plan B on, to do an elimination rule on, I recommend you start with existential sentences. Okay, I know existential elimination can be confusing, but you're probably going to have to do it eventually anyway. If this is a premise, you're probably going to have to use existential elimination, and it is going to make things simpler if you do it first. So, existential elimination, let's look at that rule. Existential elimination, here it is. So it says, when I have an existential sentence, existential quantifier, some sentence A that contains one or more occurrences of that variable from the quantifier, I want a subproof where I drop the quantifier and replace all occurrences of that variable x with some name c that I haven't seen before, and the subproof ends with whatever my current goal is. Okay. Essentially, this sentence tells me something is like this thing in the brackets. That thing in the brackets tells me that it tells me some property that this object has. When I start the subproof with a new name, effectively what I'm doing is just saying, so this tells me there's somebody like that, I'm just going to give it a name now. So we haven't used any names yet, so I'm going to put A in there. What do I know about A? Well, that's the name I'm putting on the thing described in this existential sentence. So I'm going to begin my subproof by assuming that the object A has that property. So assume A is not D and not C. And how is my subproof going to end? I'm going to make a bunch of space because I'm going to be working in here. It's going to end with exactly what my current goal is. Okay. So I'll be getting this last thing by existential elimination on line 2 and subproof from 3 to whatever line this turns out to be. Right now it says 9, but I don't know how many lines I'm going to need here, so I'll leave that blank for now. Okay. We've written down something new, so we start over again. I think plan A if I can. This is my new goal. Again, it's an existentially quantified thing. I'm not immediately sure that I can get that, so I'm going to go to plan B. Plan B is elimination rules working forwards. Now I have 3 things I could do an elimination rule on. There's an and elimination is easy. Let's just get those things out. So I can get not DA by and elimination on line 3. I can also get not CA by the same thing. Okay, we've written new things. We start over again. I still don't know about that thing at the end. Now if I'm doing elimination rules working forwards, well, I've got 5 things now. I'm going to ignore line 3 because I've done as many elimination rules on that as I can. Line 2 I've already eliminated, so I'm looking at 1, 4, and 5. You do have a negation elimination rule, but that's lowest priority, remember, when we're doing plan B, right? The only way these negation sentences are going to help me with an elimination rule going forward is by getting a contradiction. Okay, maybe I'll do that eventually, but let's leave it off for now. Universal elimination, though, that's one of our easy rules. So remember the quantifier elimination introduction rules. One of the existential rules is complicated. One of the universal rules is complicated. The other 2 are easy. We've done one of the hard rules for existential. The existential elimination requires you to make sure that you pick a name you haven't used before. Universal elimination, though, is easy. So I already know that this thing in the square brackets is true for anything. No matter what I put in for x, I get something true. Well, the universal elimination rule lets me put whatever I want in for x. So let's copy the thing in the brackets. We have existential y, bxy, arrow, dx, or cx. Okay, the rule tells me replace the x's with any name I want. Any name I want, that means it can be one I've used before. So why don't we do that? Let's put A in. Let's try putting A here and here and here. Okay, and then the rule is universal elimination on line 1. Okay, I've put down something new. We start the process over again. I still don't trust that existential quantifier at the bottom, so I'm not doing plan A. If I'm doing plan B, I have a new thing I can do an elimination rule on. Line 6. But what's the connective here? It's an arrow. Arrow elimination, remember, needs more than just the arrow. As well as A, arrow B, I need to have A, because arrow elimination wants to cite both of those lines. So if I'm going to try and get this consequent here, dA or CA, let's say I do that partway down. So if I try to get dA or CA by arrow elimination on line 6, I need to first get existential y BA y. So let's think about that. Can I get this thing? Can I get this thing? What do you think? I'm not sure. Well, this is interesting. Here's something you might notice. If I did get that, then I'd have this. But if I have this, dA or CA, that looks like it should get me a contradiction. dA or CA, that can't be true, right? Because these two lines tell me both of those things are false. I think that means, so first of all, that means I shouldn't be able to derive this. I shouldn't be able to find out that exists y BA y. But that should mean that I can derive its negation, in fact, right? Because if this were true, then I'd have this thing, but that leads to a contradiction. Maybe I can use that. I bet I can do that. Let's think this way. Let's exploit that to our advantage. Okay, I think I can get not exists y BA y. How would that work? Well, with negation introduction, because that's the main connective here. So say I then have a subproof for negation introduction. I assume exists y BA y. The rule wants me then to get a contradiction, which I think I can do because if I have this, then these two things work together to get me dA or CA. And I think I can fill in some steps to get me from here to there. Sorry, let me just fill this in. This is arrow elimination on 6. Let's clear out this empty space. On 6 and 7. I think if I fill this stuff in, that turned into ands. If I fill in these lines, I think I can get from dA or CA down to a contradiction. That would get me this. Can this somehow get me down to here? I think it can. Let me show you a way to think about this. Okay. I've told you that you only need what the textbook calls basic rules, basic natural deduction rules. There are also what we call derived rules. It's up to you whether you decide to memorize these or not, but some of them are very useful. You never need them. Anything that you can prove, any derivation you can do by means of derived rules, you can do by means of just basic rules. So if you have trouble memorizing rules, then maybe don't worry about the derived rules. But if you find yourself getting stuck, they can be helpful. They can give you shortcuts. If you don't have trouble memorizing rules, then it helps to have extra arrows in your quiver, so to speak. Now, some of these are also helpful for understanding what quantified sentences say, and that can help you with your interpretations and your translations. I'm going to tell you about these ones in particular. CQ stands for change of quantifiers. Okay. Here's the handy rule. Whenever you have a quantifier and a negation, you can change the order of those two things. That is, move the negation to the other side of the quantifier as long as you also change the kind of quantifier. So when you have for all x not, you can replace that with not exists x. When you have not exists x, you can replace it with for all x not. When you have exists x not, you can replace it with not for all x. When you have not for all x, you can replace it with exists x not. How's that useful up here? Look at this thing. I have a negation and a quantifier. Suppose I had that. Then I can write for all x not bay. Isn't that nice? So that would be change of quantifiers. But now look, that's exactly the kind of thing that I would need for existential introduction here. Okay, let's see if we can fill this in. First of all, here's just an exercise in TFL. Suppose I'm going to fill in the gaps here. We'll see if it works. So we have DA or CA. I'm going to use these two things to get a contradiction. Well, I have an OR sentence. I'm going to try OR elimination. Okay. So OR elimination, we're doing a plan B type of thing here. OR elimination says give me two subproofs. They're going to start with the two disjuncts from my OR, and both subproofs are going to end with whatever goal it is I'm trying to get. In this case, a contradiction. So this is from OR elimination on the OR sentence, line 8, and these subproofs. In this case, I can see they're going to be 2 lines each. So I'll just put those line numbers in. Okay, so I want to get from the assumption of DA to a contradiction. Well, I have not DA on line 4, so negation elimination. Depending on your textbook, this might be called contradiction introduction. It's the same rule. So negation elimination, I cite line 4 and line 9. Down here, same kind of thing. I have not C on line 5, and I have not CA on line 5, and I have CA on line 11. Okay. I think this is done. Let's go fill in line numbers. After I get to the end, I'll go back and step you through how we did this. Okay. Not introduction, that cites a subproof where you start by assuming exists y, b, a, y, and get to a contradiction. That looks like 7 to 13. Change of quantifiers, that just cites one line. Existential introduction, that also cites just one line. So notice the pattern here is, if we read this backwards, it looks just like universal introduction going forward. So universal introduction, we drop the quantifier and replace that variable x with any name we liked. That's how we got from 1 to 6. If I were working backwards from 16 to 15, you drop the existential quantifier and replace the variable z with any name you like, in this case a. They're mirror images of each other. Okay. Existential elimination, that cites the existential sentence on line 2, and then the subproof from 3 to 16. Let's see if I did this right. Oh, I did something wrong. Line 15. Oh, I see what's happened here. I mixed up my quantifiers. There we go. I had for all x instead of for all y. Let's try this again. Congratulations. Okay, that does work. I'm going to scrap all of this and start from the beginning, just to step you through again how we did this. I'll move quicker. Okay, start over. First thing we always do, put in the conclusion we're going for. Okay, first step I did, I said we're not doing plan A working backwards because this is an existential sentence. So we're doing plan B going forwards. If I'm choosing between 1 and 2, which one to eliminate, I always like to do existential elimination first. So existential elimination says give me a subproof. In the subproof, we start off by assuming the thing that we had in the brackets of your existential sentence, but replacing the variable with a new name. We haven't used A before, so I'm going to use that. The subproof ends with whatever your current goal is. So this is existential elimination using the existential on 2 and subproof from 3 to whatever. Add space. Okay. I'm still doing plan B, so not DA, that's an elimination rule from 3, not CA, and elimination on 3 again. Okay, I can also eliminate this thing up here, so I'll get, let me just copy that, replace the variable x with a name. Universal elimination doesn't tell me I have to put in a new name, so I use the one that I had before. Might as well put A in there. Okay. At this point I said I have an arrow sentence I might want to eliminate. I started thinking through what happens if I assume this, or sorry, if I get this thing. Right? If I get the antecedent of this, that's what I would need in order to do arrow elimination on here. And I persuaded myself that not only would I not be able to get that, but that I could show it was false. Right? I started thinking, if I want to do this for plan B, it's not going to work. But also, the reason why it's not going to work is that it would lead to a contradiction. If you can show that something leads to a contradiction, you can show it's false. If you can show it's false, then you can get its negation. I'm going to step through the rest of this now using just basic rules. So suppose I thought that through, and I thought this must be false. That might persuade me that, this sentence, I'll just write it out, not exists y, b, a, y. That sentence has to be true. Even if I'm not using the change of quantifiers rule, I do want you to be able to notice that that means the same thing as for all y, not b, a, y. Okay. When you're doing translations and interpretations, you need to be able to see that these two things say the same thing. Now, if I know that that's the same as this, then that tells me I think I can do plan A after all. Because if I can derive this thing, that's what I would need for existential introduction down here. Remember, the deal with existentials, with or when you're thinking about plan A, is not that you never do it. It's not that you don't ever use the or introduction rule, the existential introduction rule. It's just that you want to make sure that you're putting in a new goal that you can actually get. So if I know I can get this thing, then I'd better get it. Okay, so let's say I thought through here and decided I do trust this existential after all. I'm going to use existential introduction working backwards, and this is my new goal. So we start the process over again. Plan A. Universal quantifier is fine for plan A. So let's say I'm getting this by universal introduction. Universal introduction says if I want to get for all y not b, a, y, then I'm going to take the universal quantifier off and replace the y with, this is one of the complicated rules, I have to pick a new name. I can't use A here. So I'll put this in instead. Okay, my new goal is not B, A, B. B is a name I haven't used before, so I can use that. I've put a new thing, so I start over again. Plan A, check the main connective. We have a main connective, it's not. That's not one of the two connectives I distrust, namely OR and existential quantifier, the two OR-like things. Okay, so I decide immediately I'm doing this by negation introduction. Oh, that's not what I want. Negation introduction wants a subproof. So I'm going to have a subproof that starts with BAB and ends with a contradiction. Okay, new situation. I have a contradiction as my goal. If I immediately saw the contradiction I was going to be able to get, then I could work backwards using contradiction introduction or negation elimination, however you want to think about it. In this case, I don't immediately see that. So if I'm thinking I'll get a contradiction right away, I'm looking for negations to eliminate. I've only got these two. All right, the lines I can appeal to are 1, 2, 3, 4, 5, 6, 7. There are negations in here, but they aren't the main connective. The main connective there is an AND. So if I'm going to immediately get a contradiction by negation elimination on something I already have, it's going to be either not DA and DA, or not CA and CA. But I don't think I can get either DA or CA from what I already have. I feel like I can see that I won't be able to get those things right away. I can see I'm going to need to use the OR. If you aren't sure, still, we'll go to the next plan. Okay, the next plan is try working forwards with elimination rules other than negation elimination, right? So, what have I got that I haven't done an elimination rule on yet? I've done this one. I could do it again. I could put something else in for x. I could put b if I like. Let's come back to that. Done elimination on this. I've eliminated this. We're skipping over these two. Here's that arrow sentence. Maybe I can do an elimination rule on here. If I were going to do an elimination rule on here, I'd need to have the antecedent. I'd need to have exist y, b a y. And that would get me dA or ca. And the way we thought this through, I thought I will be able to get those things, and those will get me a contradiction. But now if I'm thinking, can I get exist y, b a y? I think I can. I think that's what line 7 lets me do. This tells me A points at little b. That tells me that A points at something. So, in other words, here's the relation between 7 and 8. If you take out the name b, put an existential quantifier on that gap, you get this thing, which is exactly the antecedent of this arrow sentence that I wanted to do an elimination rule on. So now that I have this, I can get the consequent by arrow elimination. So that's arrow sentence on 6, antecedent on 8. And now I have an OR that I can do OR elimination on, and this looks just like we had last time. So two subproofs, assume dA, assume CA. At the end of each subproof, I'm going to get a contradiction. So that lets me get the contradiction by OR elimination on the OR sentence on 9, subproof 10 to 11, subproof 12 to 13. dA, that contradicts not dA on line 4, so negation elimination on 4 and 10. Likewise, CA contradicts not CA, not elimination on 5 and 12. And now I can fill in line numbers down here. Negation introduction cites a subproof that goes from 7 to 14. By the way, here's a quick way you can fill things in at the end. If you've been following my plan A, plan B, plan C, you are almost always going to wind up on each line citing the line right before it, possibly along with some other ones, right? So this is going to be 15. This will be existential introduction on 16. Existential elimination cites the OR sentence and a subproof. Let's suppose that ends on 17. I haven't even looked. Let's hit check proof. There were errors. I cited too many lines on here. Oh, what did I put 9? That was a remnant. Check again. There we go. It's done. And this time, we used only basic rules. We didn't use the change of quantifiers rule. We did think in terms of what that existential sentence said. And that helped us see that we would be able to get this. But we didn't actually use the change of quantifiers rule. Okay, I'll stop there. If you got questions, you know what to do. Send me an email.